Welcome to Chapter 4, the final chapter of the RAG Introduction series. In this lecture, we'll cover everything you need to deploy RAG systems to production. You'll learn about microservice architecture, performance optimization through caching and batch processing, comprehensive monitoring and evaluation, and distributed processing for scale. By the end, you'll have a complete understanding of production-grade RAG system design. Production RAG systems benefit from microservice architecture. We separate into 5 main services. The ingestion service handles document intake and preprocessing. The embedding service manages vectorization, potentially using GPU acceleration. The search service wraps the vector database and re-ranking logic. The generation service handles LLM API calls. The API gateway manages authentication, routing, and rate limiting. This separation enables independent scaling, for example scaling embedding service during bulk indexing, and fault isolation where one service failure doesn't crash the entire system. FastAPI is an excellent choice for building these services. Caching is essential for RAG performance and cost control. We implement a 2-level cache hierarchy. L1 is an in-memory LRU cache, extremely fast but limited in size. L2 is Redis, distributed and persistent with larger capacity. When a query arrives, we check L1 first. On a miss, we check L2. If found in L2, we promote to L1 for faster future access. Only on complete misdue, we execute the expensive RAG pipeline. With a 75% hit rate, 3/4 of queries skip the embedding and LLM calls entirely, so API cost falls by roughly the same fraction, and those cached queries return in milliseconds instead of seconds. Cache keys are generated from query and parameters using MD5 hash, with configurable TTL typically set to 1 hour. When indexing large document collections, batch processing is crucial. Instead of processing documents one at a time, we split them into batches, typically 50 documents each, and process batches in parallel using multiple workers. A semaphore limits concurrent operations to prevent resource exhaustion. With 4 workers, you can achieve roughly 4 times the throughput compared to sequential processing. The async pattern using Asyncio integrates well with FastAPI. Always include progress tracking for long-running indexing jobs, giving users visibility into the process. Production systems require comprehensive monitoring. Track 4 categories of metrics. Latency metrics include search time, generation time, and total processing time. Accuracy metrics measure precision, recall, and F1 score. Relevance metrics track MRR and relevance scores. Cost metrics monitor API calls and token usage. Prometheus is the standard for metrics collection, using counters for totals, histograms for latency distributions, and gauges for current values. Visualize everything in Grafana dashboards. Use Python decorators to automatically track metrics on every function call without cluttering business logic. Evaluating RAG quality requires both retrieval and generation metrics. For retrieval, measure precision at K, showing how many of the top K results are relevant, recall showing how many relevant documents were found, and MRR, mean reciprocal rank, measuring how quickly the first relevant result appears. For answer quality, use LLM as judge where another LLM scores answers on accuracy, relevance, and completeness on a 1 to 5 scale. Build automated evaluation pipelines with test query sets and ground truth answers, integrating with CI/CD to catch quality regressions before deployment. A/B testing enables data-driven optimization of RAG configurations. Create experiments comparing different settings, like chunk sizes or re-ranking methods. Traffic is deterministically assigned based on user ID hash, ensuring each user consistently sees the same variant. Run multiple experiments simultaneously on different aspects of the system. Collect metrics per variant including mean latency, standard deviation, and sample counts. The framework records mean, standard deviation, and sample count per variant, and a separate significance test on those numbers tells you whether a difference is real or just random variation. This systematic approach replaces guesswork with evidence-based optimization. For handling high query volumes and large-scale indexing, Celery provides distributed task processing. Tasks are defined with decorators and submitted to queues. Redis serves as the message broker. Multiple Celery workers consume tasks from queues and execute them. Separate queues for indexing, embedding, and query tasks allow different scaling and prioritization. The async API pattern returns a task ID immediately, allowing clients to poll for completion status. Built-in retry logic with exponential backoff handles transient failures gracefully. This architecture scales horizontally by adding more workers. Let me share essential best practices for production RAG. For monitoring, use Prometheus and Grafana to visualize everything from latency to error rates. For logging, use structured JSON logs that can be queried in Elasticsearch. For security, implement API key authentication, rate limiting to prevent abuse, and thorough input validation to prevent injection attacks. For CI/CD, automate testing including RAG quality metrics and use staged deployment with rollback capability. For disaster recovery, maintain regular backups, database replication, and documented failover procedures. For scaling, design for horizontal scaling from day one with load balancing across instances. Congratulations on completing the RAG Introduction series. Let's recap Chapter 4's key points. Microservice architecture enables independent scaling and fault isolation. Multi-level caching dramatically reduces latency and API costs. Comprehensive metrics and A/B testing drive continuous, data-driven improvement. Celery enables distributed processing for scale and reliability. Production requires attention to security, monitoring, and disaster recovery. You now have the knowledge to build production-grade RAG systems. Your next steps: build your first RAG system with a small document collection, experiment with advanced techniques like re-ranking and hybrid search, then deploy to production following the patterns we discussed. Thank you for learning with us.